That raw chicken breast sitting in your grocery cart has been mechanically injected with an engineered saltwater and phosphate solution that fundamentally rewires how your cells manage hydration the moment you digest it. You think you are buying a pure, single-ingredient muscle protein, but behind the scenes of commercial poultry processing, industrial needles have forced a dense liquid matrix deep into the intracellular spaces of the meat. This practice, known quietly across the food industry as plumping, alters the physical architecture of the protein fibers to lock in water that would otherwise evaporate on the shelf. When that altered protein hits your digestive tract, it delivers a massive hidden surge of sodium and inorganic phosphates straight into your bloodstream, triggering an immediate osmotic shift that forces your cells to fight for their fluid balance. What you are about to understand is the exact cellular machinery that governs this interaction. We are going to look closely at the sodium-potassium adenosine triphosphatase pump, the fragile mineral balance inside your vascular walls, and the precise way your kidneys process artificial phosphate additives compared to naturally occurring minerals. Think about what happens when you step into your kitchen on a Tuesday evening. You unwrap a package of fresh, raw poultry breasts, and they look plump, glistening, and perfectly tender. You place the meat into a hot skillet, expecting a clean sear, but within 90 seconds, the pan fills with a milky, bubbling liquid. Have you ever wondered where all that water actually came from? It did not come from the natural biology of the bird. In standard industrial processing, up to 15% of that chicken's total weight consists of an injected solution of purified water, sodium chloride, and synthetic sodium tripolyphosphate. The industry calls it moisture enhancement, but at a biological level, it turns a clean cut of meat into a high-sodium delivery vehicle. To understand why this matters to your biology, we have to look at a landmark study published by Dr. Massimiliano Petracci and his research team in 2013. The researchers demonstrated that modern, fast-growing poultry muscle fibers often suffer from structural weaknesses that cause raw meat to lose moisture rapidly. To mask this degradation and artificially increase product weight, industrial processors inject high-pressure brine solutions that chemically force the muscle filaments, known as actin and myosin, to swell and trap water. The chemical binding is so aggressive that it prevents the water from escaping until high heat ruptures the protein bonds in your skillet. Now, imagine what happens when this altered food reaches your small intestine. Your enterocytes, the specialized epithelial cells lining your gut, are designed to absorb nutrients through precise biological gates. Naturally occurring sodium in whole, unprocessed meat sits at roughly 60 to 70 milligrams per 4-ounce serving. In injected poultry, that number frequently climbs to 300, 400, or even 500 milligrams in that exact same 4-ounce cut. That sudden flood of sodium enters your capillary network, instantly raising the osmolarity of your extracellular fluid. Your blood plasma becomes hypertonic. Every single red blood cell and endothelial cell lining your blood vessels suddenly experiences an osmotic pressure gradient, pulling water out of the cells and into the bloodstream to dilute the incoming salt. Your cells do not take this passively. Deep within every cellular membrane in your body sits a microscopic engine called the sodium-potassium pump. This protein complex burns through roughly 1/3 of all the energy your body produces every single day just to pump 3 sodium ions out of the cell while pulling 2 potassium ions in. When a hidden flood of industrial brine enters your circulation, these cellular pumps are forced to work at maximum capacity to prevent your cells from collapsing into osmotic dehydration. It is remarkable how much cellular energy goes into simply stabilizing our internal fluid dynamics after what was supposed to be a simple, clean meal. If you are enjoying this breakdown of how everyday kitchen ingredients manipulate our cellular machinery, take a quick moment right now to subscribe and leave a comment below. When you engage with these deep dives, it directly signals that there is a real appetite for genuine nutritional biochemistry, and it allows this channel to keep investigating the exact biological mechanisms hidden inside our food supply. Now, let us move past the sodium and look at the second, far more deceptive compound lurking inside that injected meat: synthetic inorganic phosphate. In nature, phosphorus is an essential mineral bound tightly within complex organic molecules like proteins and phytates. When you consume phosphorus from a whole, natural source like pumpkin seeds or fresh pastured eggs, your digestive enzymes must slowly break those organic bonds. Because of that natural time-release mechanism, your body only absorbs between 40 and 60% of organic food-bound phosphorus over several hours. Synthetic sodium tripolyphosphate is entirely different, because it is an inorganic, free-floating chemical additive designed to act as an industrial emulsifier. Your digestive tract absorbs between 90 and 100% of it almost instantly. It does not require enzymatic breakdown. It diffuses straight across your intestinal wall and enters your bloodstream as a sudden, concentrated wave of inorganic phosphate ions. This is where the high-energy biology really gets fascinating. In 2012, an extensive clinical investigation led by Dr. Eberhard Ritz examined how elevated serum levels of inorganic phosphate impact the human vascular system. The findings were undeniable. When your blood experiences a rapid spike in inorganic phosphate, your vascular endothelial cells, the delicate, single-cell thick inner wallpaper of your entire circulatory system, suffer immediate biological stress. The excess phosphate ions begin binding with circulating ionized calcium in your blood. Under normal conditions, your kidneys, guided by parathyroid hormone and a specialized hormone called fibroblast growth factor 23, would filter this excess without issue. But when synthetic phosphates hit your bloodstream in large, rapid pulses from processed poultry, your kidneys are temporarily overwhelmed. Your endothelial cells respond to this chemical stress by temporarily down-regulating their production of nitric oxide. Nitric oxide is the master signaling gas that tells your smooth vascular muscle to relax, widen, and lower your blood pressure. Within 2 hours of eating a meal loaded with synthetic phosphates and hidden brine, your microvascular vessels lose their natural elasticity. They stiffen. The resistance against which your heart must pump increases measurably, not because you are stressed or sedentary, but because the biological software inside your vascular wall has been temporarily scrambled by synthetic processing aids. Let us put this into a concrete kitchen perspective. When you buy genuine, unadulterated pastured poultry, you are feeding your cells an ideal, nutrient-dense package. Natural chicken muscle contains a rich abundance of intracellular potassium, roughly 300 to 400 milligrams per serving, with only a tiny fraction of natural sodium. This natural 4-to-1 potassium to sodium ratio supports your cellular voltage, relaxes your vascular tone, and keeps your cellular hydration perfectly balanced inside the cell walls. When you eat plumped, brine-injected commercial chicken, you completely invert that biological ratio. You are suddenly delivering more sodium than potassium, alongside a payload of free inorganic phosphates that your evolutionary biology was never designed to process in rapid boluses. Your body shifts from a state of cellular nourishment into a state of active metabolic defense, pulling water out of your intracellular space to manage the extracellular salt load, while your kidneys work overtime to clear the synthetic mineral surplus. The good news is that once you understand this mechanism, you can take complete control over what happens at your own dinner table. You do not have to give up poultry. You simply need to apply 3 precise, practical nutritional strategies to protect your cellular terrain. First, master the retail label decoding protocol. When you are in the grocery aisle, ignore the marketing phrases on the front of the packaging like all natural or farm fresh, which have virtually zero regulatory meaning regarding brine injection. Instead, flip the package over and inspect the fine print beneath the primary weight label and the ingredients list. Look specifically for phrases like containing up to 15% of a solution of water, salt, and sodium phosphates, or seasoned with chicken broth. If an unprocessed raw chicken breast lists anything other than 100% chicken, or if the sodium content exceeds 80 milligrams per 4-ounce serving, it has been mechanically plumped. Seek out air-chilled poultry that explicitly states no added solutions or retained water under 1%. Second, deploy the cellular counterbalance protocol whenever you consume restaurant or commercial poultry. Because you cannot always control the sourcing of your meat when eating out, you can actively buffer your cellular sodium-potassium pump by pairing that protein with high-potassium, bioavailable plant foods. For every 4-ounce serving of potentially plumped chicken, consume at least 400 milligrams of food-based potassium. You can achieve this exact cellular ratio by adding 1 cup of steamed spinach, half a medium avocado, or a generous serving of roasted zucchini seasoned with fresh lemon juice. The natural potassium and bioflavonoids act as an immediate cellular shield, providing the exact counterions your sodium-potassium pumps need to maintain intracellular hydration without taxing your vascular system. Third, implement a gentle citrus and acid soak technique before cooking if you suspect your chicken has been enhanced. While you cannot extract the water that was injected deep into the inner muscle filaments, soaking your raw poultry cuts in cold, filtered water with 2 tablespoons of fresh lemon juice or raw apple cider vinegar for 20 minutes creates an external osmotic pull. This mild acidic environment helps break the weak hydrogen bonds of surface-level phosphate additives, drawing unbound industrial salts out into the water bath, which you then discard and pat dry with unbleached paper towels before cooking. When you look at the food on your plate through the lens of cellular biology, your entire perspective shifts. You realize that food is never just calories, macros, or simple fuel. Food is biological information. It is software that directly instructs your cell membranes how to regulate fluid, tells your blood vessels whether to expand or constrict, and dictates how hard your organs must labor just to maintain internal balance. You are no longer just someone cooking dinner. You are the biological architect of your own internal ecosystem. Look in your refrigerator or freezer tonight. Does your current chicken package list any added salt solutions? Make sure to like this video right now so you can use this precise label guide and preparation protocol as a quick bookmark next time you are standing in the meat aisle deciding what to buy. Every single meal is an opportunity to decode the hidden science of our modern food system and give your cells the exact biological environment they need to thrive. Subscribe to Nutrition Decoded right now so you do not miss the next deep dive investigation we are already researching for you. Keep questioning your ingredients, keep learning the real science, and take care of your cells.